Hi, I'm Max, engineer at Tameson, and today we're going to talk about the difference between AC and DC coils for solenoid valves. These products can be bought from Tameson, your online resource for all fluid control products. Let's get into it. So in this video we'll talk about how solenoid valves work, the workings of a DC coil, the workings of an AC coil, and the difference between an AC and DC coil. A solenoid valve works using the following principle. When current flows through the coil, it generates a magnetic field which attracts the armature towards the center of the coil. And since the armature is drawn towards the center, regardless of the polarity of the current, an opposing force is needed to return the armature into its starting position when there is no electricity. And this is achieved by using a spring. So in order to actually use the valve, the magnetic force generated by the coil must be larger than the spring force. For a DC coil, the coil is energized, allowing the magnetic force generated by the coil to overcome the spring force, and thus the valve is open. When it is de-energized, the spring force closes the valve again. So with AC coils this is a bit more complicated. AC switches polarity, and therefore twice per period the current in the coil is zero, and thus the magnetic force is zero. And this is a problem because the spring force is constantly pulling the armature down. This results in a vibration of the armature, which can produce a humming sound and can cause stress to the components. So to fix this, a copper ring is installed around the armature, and this ring stores some of the magnetic energy such that the armature will not vibrate. When a solenoid valve goes from the off to the on state, the coil should initially generate more force in order to overcome the spring tension combined with the pressure of the fluid and the friction of the armature. Once the armature is lifted, the coil can decrease the generated force in order to reduce power consumption and heating. DC coils have a slower response time compared to AC coils due to the resistivity. And as a result, DC coils will waste a considerable amount of energy in the open state because more electricity is needed at higher resistivity. In other words, AC solenoid valves are more energy efficient compared to DC valves. But as explained, AC valves do come with other drawbacks, such as possible vibrations. So all in all, a lot of aspects to consider when choosing an AC or DC coil, and both have their drawbacks and upsides. In general, selection is done based on what kind of voltage you have available at the location of installation. If you enjoyed this video, please give it a like and subscribe for more. And if you have any questions about AC or DC coils, or if you need help selecting the right coil for your application, please contact me or anyone else from Tameson.